Can you see my
Yeah.
screen?
Yes. Yes.
Okay,
Yes.
okay. Okay. This paper was published probably 2023. Yeah, yeah. So, the title is an autonomous non-monolithic agent with multimode exploration based on options framework. Okay, my name is Jae Yoon Kim. Just call me Johnny. I'm a PhD student in University of Technology, Sydney. At the moment, my thesis is under examination. Okay. Okay. Let's just see the next page. Yeah. So this paper is talking about the explanation, especially uh, what is the how real human, think about the something with explanation methodology, human explanation methodology. That one is the much a little bit pretty much different from the currently the mostly used the explanation methodology in reinforcement learning. So let's just see the if you see here the mm, here okay. So there are two at the moment the explanation methodology regarding the monolithic issues. It means the most of RL explanation has uh, been conducted with some kind of this kind of uh, methodology. Yeah, it means the final action is the an action of behavior policy plus a random noise. So it means the an agent output his action, and with that action is added to a random noise. So random noise is kind of the role of explanation. But problem is the human what is it uh, explanation does not work like this. Human how human conduct the explanation. Let's just this one. Uh, non monolithic explanation. It means the final action is the an action of explanation behavior policy, exploitation behavior policy, or an action of explanation behavior policy. It means human think about the some kind of the uh, behavior depending on the mode. Like the in this case, I want to use the exploitation. In this case, I want to challenge some more, so with some explanation policy. Yeah, this is really human conduct some kind of explanation between the explanation and exploitation. So, uh, okay, so let's just see the next page. Uh, so the again, if we see the some kind of the non-monolithic, noise-based monolithic formation like this one. This is the line is kind of exploitation, but the final action is the this circle. It means some kind of noise added to the action, and the final uh, action go to the environment. So, so yeah, this kind of things we call noise-based monolithic explanation. But the non-monolithic explanation like this one. So in this case, this circle, this is explanation. So this line just three steps. During the three steps, exploitation happens, take place. Yeah, so takes place. So in this case, does not add any noise, just the exploitation action happens. And the explanation action takes place during the three steps like this. This in this case two steps, and this is just for example. So anyway, uh, so um, this kind of methodology we call it the non-monolithic explanation. Monolithic means the added to the exploitation or not. The explanation is added to the exploitation or not. So added monolithic, not added, so non-monolithic. Okay. So the reference paper is this one. When should agent to explore? So this one is as I know, the Google researcher. So they're gonna uh, uh, publish this papers. So probably 2021. So I read this one, and also I get some idea from based on the hierarchical reinforcement learning options framework. So I write this paper. Okay, but this paper has some kind of the limitations. So this is only one mode explanation, and also the period of explanation is not variable. So I want to more variable period of the explanation and more mode for explanation. Yeah. So and also this is not a simple thread showed hyperparameter function, but the natural switching mechanism. Yeah, it means this is this uses just the simple threshold hyperparameter functions for the switching mode. Between the exploitation and explanation. I wanted to some kind of think about the more natural switching mechanism. It means the kind of the more autonomous agent for uh, selecting the mode by the agent, not just a simple hyperparameter function, threshold hyperparameter function. Okay. So, uh, so, so in order to do that, I'm thinking about some kind of the hierarchical reinforcement learning as an option framework. That's what I'm going to use for the non-monolithic explanation. Okay, so okay, let's just so this one is this one is as a mode switching controller. This when should agent explore use this function. So value promise discrepancy. So value difference between the steps. Yeah. So but I don't want to use this kind of simple function. So I want to more I want to more the autonomous and more mode and more much various the explanation period. Okay, how to do? Let's see so the what he did in the reference paper. Just he used some kind of the offline off fallacy. So off fallacy, and based on that homostasis, as I show you some kind of the function. So that based on that function, this controller works, and uh, according to the threshold. So finally, action is connected to the higher level, low level fallacy. Originally, the reference paper does not use the what is it? Higher level reinforcement learning, but in my case, just for test and compare with my one, and so I just use the hierarchical reinforcement learning. But the original paper does not use this kind of hierarchical reinforcement. Just only one level. So autonomous, it's kind of the atomic RL. Anyway, so this kind of the simple one is the, as I told you, there is some issues. Just fix the switching, fix the period of the explanation, and also the only one mode. Okay, Opalashi or PPO, or we can use just random like this, just based on the design. Okay, so just one mode, and also simple one. But I don't want this kind of things. I want more the autonomous and more various. So how to do? So in my case, I want to implement the HRL with 3 levels. So the highest level, top level, is kind of the select the role of switching mode controller. So this agent, what is it? decide which higher level, middle level of the 3 policies will be selected. Okay, so in the middle level, there are three agents. So that agents all are different according to the what is it, entropy. So entropy degree. So this one is the random. So entropy is so big one, and this is a PPO, so on policy. This one is O policy TD3. So entropy is the highest, and next to this one, next the
Maybe,
lowest.
Johnny, maybe you can insist more on the experimental results and the use cases, because this scheme maybe is not, it's a bit difficult to appreciate if we don't understand what is the use case, what is the data, what is the result.
Uh, I don't prepare for that kind of use case at the moment. I can just only explain with this one. This is used for my presentation in the what is the conference. Okay. Sorry. Only just
The question, I think overall in this webinar, what we want to do is at the end do some trading robots. But of course, we understand it may not be the use case, always the use case of the new technologies. So in this model, of course, looks very interesting, but what can we do of it? How can we make money with it? How can we get use case? I mean, that should be the focus. It's short presentation in 15 minutes. That should be the focus of the presentation. And then you explain the architecture, because here you see these 2 diagrams. I mean, I'm not an expert, so it's very difficult to see any difference between the left and the right. I see there is some difference, but it's difficult to really appreciate them. You see what I mean?
so what do you want? So you want me to start the presentation?
No. I want that you go to the slide with experiments where you show the tasks. Why your model on the right
I
is better
explain.
at which task than model on the left.
Yeah, so I will explain my experiments later. Okay,
Yeah.
to the sheet. Okay, just wait for my presentation. Okay.
Okay.
Okay. So this top top agent is selecting the which one is the at the moment the connected to the low level. This low level is connected to environment. So this one is deciding which middle level, which one of the middle levels can be connected to the lowest level. So this is much autonomous, and also the more we can put more entropy degrees, not only one mode, so several modes. And we in the experiment we for this decision we are trying to evaluate this one with this and this one of the TD3 in the middle level and also lower level, and we try to evaluate, and that one can be used for the selection. Okay, so those kind of the mechanism is working here. So in the case, so yeah, so I already explained. So guided explanation, we use this one, and also we also modified the loss function finally. So we try to take advantage of this kind of mechanism in this in this model. Okay, and the all code here, and also yeah. So I tested this one is the OpenAI gym, and this one is the what is it? Enter push, enter domain. So enter push. So I do not test this one in the what is it? Your domain, or what is the fin RL? You know, the usually what is market, those kind of thing. So I did not use. Just this one is used for the OpenAI gym and in enter domain, and so especially enter push. So in that case, the red one is the our one at the time, our model. So performance better than the other three ones, three models. So first model is just the PPO, this one, and this one is the pink is the uniform random, and the blue one is open fallacy. Okay, this one is our model. So in the case, the one is the performance is the best one, and the success rate also is quickly takes place. And in that case, this one is our model. Try not use the random fallacy in the middle. If you see here, up to this one is just the initial process. I just put the certain steps until certain steps. We just in our model we just operate on the random fallacy, but after that level, after certain steps, just top level fallacy decide which fallacy in the middle level is used or not. So okay, so exploitation mode, if you see the linearly is used largely, and the other one is explanation mode is used like this kind of process is used. So it's very interesting autonomous operation. So he decides this kind of things. So between the three policies, among the three policies, okay. And this one is the Interpol. In this case, our policy a little bit not good enough. But the interesting is like the performance drop, but they try to avoid the this drop during the start for small steps. So try to the exit this drops, finally go again, go rise. Yeah, okay. Performance is good. Yeah. Anyway, so this one also, in this case, the random policy is used a lot, and but exploitation policy a little bit smaller than the previous one, and explanation policy also is used much than the previous task. Yeah. Okay, so this is end 4. Okay. Yeah, and evaluation study. This is just some kind of the with modification of reward and loss. Wow. In this case, what kind of happens, and also without the loss modification, without reward modification, and full model. Yeah. So in that case, what kind of situation happens? Yeah. So in that case, yeah. Okay. Yeah. So full condition, full. With full condition at the time, our model shows the best performance. Okay, so anyway, so I'm thinking this kind of things can be researched further to improve this this methodology in the hierarchical reinforcement learning, and also it should be more much considered in the other domain. Yeah. Okay. Thank you. Okay. Do you have
So,
any? Yeah.
my question, yes, maybe future research, in my opinion, maybe focus more on applications. Because you see, we have so many applications of reinforcement learning, of AI, and I think this, in my opinion, this presentation may be too much theory, not enough practice. And people, they want to see practice. They want to see money. They want to see results. Something where we see, yes, we put money on this. That's basically what you need to show. And in this presentation, of course, I think very interesting topic, everything, but maybe need to insist more, because you showed some results, too many results. Maybe 1, 2 benchmarks is enough to show what value of the improvement. Here we see maybe too many information. We don't know what to do with it. And yes, so in my opinion, that should be the future work about. It's my viewpoint from viewpoint of what we are doing. We are building finance reinforcement learning library, platform, everything. And so we want to propose to the people the best algorithm, the best agents, the best robots. And that's the question that is my viewpoint.
Yeah. So my my more researches at the moment. I already published 3 papers. So all 3 papers are related to non-monolithic explanation. So I adapt this kind of methodology, not hierarchical reinforcement learning, but in the other area like the pre-training. The pre-training fine-tuning case, we can use this kind of methodology, and also offline to online RL also. Yeah, so also we can use those kind of. Yeah, so if you see my paper, the other papers, you can see the maybe later, maybe if I have the opportunity to introduce some kind of the other papers, maybe I can show the the other result. Okay. Yeah.
Maybe you see, I think what would be interesting is now at this point, if you can make experiment in finance, in trading, You show your method works better than the others. We see more profits, and then we see, oh yes, because you see, that's the only thing people care about. You know, you can make complex agents with people that don't care. They don't care. They want to see where I put money. That's all.
Money. Problem is in finance, the agent.
And I think that's why I like finance, because when you have this viewpoint of finance, everything becomes more practical. And you can, because you can always get lost into the theories, the algorithm. There's always something new, etc. And maybe you can get a bit lost. There is so many things to do. And I think have this viewpoint, I think, is very practical. It helps to be more practical.
And also the higher dimensional space, the space, state space, also action space. Probably, we need more research, to adapt this kind of methodology to finance domain. Yeah, really critical, crucial domain. If we do not use if we use this kind of methodology wrongly, probably we lose the money. So we have to.
So you see, that's the question. I mean, you see, that's the thing. If at the end you lose money, they say, okay, it doesn't mean the method is wrong, but you need more work before getting incorporated.
Academic,
Yes.
academic, yes.
So I think we can stop there. I think now you have a little more information, and once you have a benchmark that shows why it works better or something, then I think it can be very interesting to have another presentation. Okay.
Anybody doesn't have any question?
Yes, maybe other people have question in the public. We have little people. Maybe Ash or someone else.
No?
Ash, you want to say something?
Like that. It is more of like, hey, we need application cases more. Because in theory, there are so many things are available. But to be very honest, if someone's practical idea becomes useful in the case scenario, that gives us a boost in the process. So what you did is a great job, but more of like, they would like to hear more practical aspects of it. What is on that table, what is proved. So it will give us all of a community boost. It is like that. And apart from that, what you did was a great work.
Yeah.
Thank you.
Okay.
So anyone else has questions? No? Okay, then we can stop here. So thank you very much, Johnny.
Okay,
and of
thank
course,
you.
welcome to the next course. We have another meeting in Thursday, I guess, this week. See you. Bye.
See you. Bye. Thank you. Bye.